All right, here we go. So, when we do the application problems, we're not going to do circle applications because you did that in previous classes. You should have, I believe, Math 3. So, and then I've never seen of an application problem that uses hyperbolas. So we're not going to do that because I don't even know where to look for those. So really the application problems are either going to be parabolas or ellipses, and you're going to see something in the wording that tells you that it's a parabola or an ellipse that you're going to use. So like this one, it says a cable TV receiving dish is in the shape of a paraboloid. A paraboloid is a 3D version of a parabola. Does that make sense? It's like a bowl, so it's 3D instead of 2 dimensions. Okay, so that's what a paraboloid is. So it says find the location of the receiver, which is placed at the focus if the dish is 6 feet across at its opening and 2 feet deep. So really, with these problems, you just want to draw a sketch so that you can figure out like how to label the points in the picture. And then once you label the points, it turns it into like a normal textbook problem. So that's the hardest part, is just figuring out how to interpret the words so that you draw it correctly. Now on these, the orientation of the parabola does not matter. It doesn't matter if it's up or down or left or right. So typically I have my parabolas going up and I put the vertex at 0, 0 because that makes my life easy, right? To put it at 0, 0 and have it going up. So I'm going to go ahead and draw my parabola like this. It says the receiver is placed at the focus. So I'm just going to pretend the focus is there. I don't know exactly where it should be, but I know that it's inside. And I know that whatever the focus is, it's a length of A up from 0, 0, right? That's what the focus is. It says the dish is 6 feet across at its opening and 2 feet deep. So I know that the opening right here, I know that that whole opening right there is 6 feet. And I know that it is 2 feet deep. So what I would like to do now is I would like to find some other points that are on the parabola. So those are the points that are at the opening. And do you guys know what the coordinates of those points would be? 3, 2, and negative 3, 2. And did they say anything about those points being straight out from the receiver, which would tell us that they're endpoints of the lattice rectum? Did they say that in the problem? No. So it would be a wrong assumption to think that these are the endpoints of the lattice rectum. A lot of students are like, oh, Miss Rice, the A value is totally 2, and so we already know where the receiver is. And that's not the case, because they didn't say anything about these being straight out from the receiver. Does that make sense? Okay, so we got to be careful there. All right, so we have that. So our goal right now is to figure out some way that we could find a value for A. So since we are looking at a parabola that goes up, could somebody maybe tell me the equation that we're using for this one? The parabola goes up.
X squared equals plus minus 4 times y.
Yeah, times y. So he already plugged in the 0, 0 for the vertex. Do we need a plus minus? It's a plus because it goes up.
Yeah.
Okay, so we already know that. So what could we use to solve for A? Because A is truly what we want here. Plug in a point. Okay, what point do you guys want to plug in? 3, 2. 3, 2. Okay, so let's do that. Don't mind me, I just did it backwards. So what are you guys getting for A? A equals 9/8. Okay, so now in these problems, it's going to be important that you explain, like when you write the sentence, because these are stories, so we write sentences, right? Okay, so it's important that when you write the sentence, you write it in a way that makes sense. So if I say, the receiver is at 0, 9/8, does that make sense?
No.
That is a silly way to answer the question, right? So how would we describe where the receiver is? Yeah.
Receiver is 9/8 of a foot up.
Yeah, is 9/8 of a foot even?
1 foot and 1.1.
Yeah. You could say 1 and 1/8, right? 1 and 1/8, or you could say 1.125. So we're going to say it like for when we do story problems, improper fractions, maybe not the best because most people don't talk like that. So we're going to say the receiver is 1 and 1/8 feet, or we could say 1.125 feet from the center of the dish. Would that make sense? Okay. Okay, go ahead and see if you can draw the picture for number 2 so that we can figure out what it is. It's a parabola, because it says paraboloid. Isn't paraboloid like the best word?
Yeah, parabola.
I want to have my child's middle name be paraboloid. Wouldn't that be incredible? Whoa, I'm going to get married. I don't have to adopt. Okay. I forgot you were going to get married, Miss Reyes.
No, I forgot the name.
Okay. Alright, so here's how I started. I've got my vertex at 0, 0. What else did you guys draw? The height is, or the depth is how much? 2 inches. Okay. Do I know how wide it is? No, that's what I'm trying to find, right? Okay. What else do I know? The focus is 1 inch. There's the focus. So, and that would be 0, 1, right? If they tell us that the focus is 1 inch from the vertex, what value do we know for sure now? We know A is 1 for sure. Okay. They want us to find the diameter of the headlamp, so they want us to know all the way across. So, unfortunately, we're not going to be able to write this whole coordinate like we did up here. Up here we knew it was 3, 2. But do we know any part of the coordinate? Okay, the y value is 2. What should I put for the x value? Can I put an x there? What could I do over here? Negative x. Okay, so at this point I've labeled as much as I can. And then I know if I can figure out this number for x, then that would tell me like half of the diameter, and then I could just multiply it by 2, right? Okay. So what are your thoughts? Write the equation for the parabola is a good place to start. So x squared again, right, because it's at 0. Equals 4ay, so just like we're starting it exactly the same way we started it before, and we know it's just plain old x squared and plain old y because we had our vertex at 0, 0 again. And then, so what numbers, what else did I know from the equation that I could put in here to help me solve? We also know that a is 1, right? So we've got 4 times 1. Actually, I'll erase this. Do we know anything else? We know that y is 2 when the x value is just x. So x is really what we're trying to solve for here. And we know that the y value is 2. So is that enough information to solve for x?
Yeah.
It is, okay. So we've got x squared equals 8, right? I want you guys to get from here to concluding what your answer is. Okay, because we're almost there, but we have just a little bit more to do. So go ahead and take a moment and finish the problem. So, what did you guys decide? Okay, so the diameter of the headlight is, and what is 5.6 inches? What was the exact form for the answer? 2 square root 8. Have you ever been at a store and seen that it said that the diameter of something was 2 square root 8 inches? It depends on what store. If Miss Rice opened a store with headlamps, it would say 2 root 8. Alright, so 5.66 makes more sense in a story problem. Okay, so next we have ellipses. Where do you guys think we're going to center an ellipse for a word problem? Where are we going to center? You guys are very chatty back there. You were paying attention, but behind you there was just a lot of noise. Okay, so to make our lives easy, we're probably going to center the ellipse at 0, 0, just because that works out nicely. All right, so it says we have a whispering gallery. The clue that this is an ellipse is it says, how high is its elliptical ceiling? So, ellipse. That's what that makes me think of. So what this means is that the room is shaped like that, and it makes it, when it's shaped like that, it makes the acoustics so that you can whisper. You can whisper on one side. Have you guys ever done the whispering thing at NC State? It's like a little bowl. It's more of the idea of the hyperbola actually, but it's like a little bowl thing. If you whisper into it, the sound bounces off, and then it's the same idea as what's happening here. All right, so Jim. Hey guys. All right, we only have a little bit longer. We got 15 minutes. We're going to try to get through both of these. So we've got Jim standing at one focus of a whispering gallery. He is 6 feet from the nearest wall. So there is Jim, 6 feet from the nearest wall. His friend is at the other focus 100 feet away. So here is his friend. Can his friend be Fred? Fred the friend? Oh, okay. So what are the coordinates of these points that I just drew? He's 6 feet away from the wall, and he and his friend are 50 feet, or they're 100 feet apart. I do that all the time. So this should be 50, 0, and negative 50, 0, because that's what makes them 100 feet apart. And then what should the other points be? 56, 0, negative 56, 0. So, since we know where the foci are, we know the value for C, right? An ellipse has a value for C, and that's how you find the focus. Can somebody tell me what the value for C is? 50, okay. All right, so they want to know two things. They want to know what the length of the whispering gallery is, and we already have enough information to do that. What's the length of the whispering gallery? The length of the whispering gallery is 112 feet. How did you do that? Addition, okay. So this 56 over here plus that 56 over there equals 112. So that's how we got that. So then we need to know how high the elliptical ceiling is at the center, which means we need to know how far this is from the center, right? So the way that I'm thinking of it is I have the radius to the left and right, correct? And I need the radius up and down. So could we start writing the equation and see if maybe we could find it? So, since our center is at 0, 0, what do we already know is in the equation? I've got something plus something, I've got it equals 1. X squared, right? Okay, and then y squared. And these didn't need numbers because they're centered at 0, 0. And if the radius to the left and right was 56, then what should go down here? 56, are you guys okay with me just writing 56 squared and not doing it? Okay. So if we know that this is 56 squared, and we know the focus is 50 away, how could we find this other number? So c squared equals, do we know which, because we have to do bigger minus smaller, do we know which one should be bigger, maybe? Yeah, possibly, I mean, from my picture, it looks like it's, I mean, logically speaking, we would expect the ceiling to not be as tall, maybe? We can go ahead and try it. If we end up getting a negative answer, and we can just switch it if the answer is the wrong sign. Okay, so c squared equals a squared minus b squared is what I'm going to do. And my c squared is 50 squared, and that's going to equal 56 squared minus b squared. And if somebody tells me that 6 squared is the answer, I'm going to be very upset. So type in your calculator 50 squared minus 56 squared, because it is not going to be 36.
Oh, I got it.
So it's negative 636 equals negative b squared, and so that means that the number underneath here would have been 636. So do we say, oh, the ceiling is 636 feet high? No, what do we say? We got to square root that. So the square root of this is what tells us. So the ceiling is, and what did you guys get? 22 feet. Is it 22? 21? 22? Okay. Oh, okay, 10 minutes. We're going to try to get the last one done. So, a bridge is built in the shape of a semi-elliptical arc. Do you guys know what a semi-elliptical arc would be? Yeah, half of an arc, because a semicircle is half of a circle. So a semi-elliptical arc is what we just drew, basically. Now, when it says choose a suitable rectangular coordinate system, we've been doing that the whole time, even though the problems didn't phrase it that way. Choosing a suitable rectangular coordinate system is us drawing it like this and putting the center at 0, 0 to make our lives easy. That's what they're talking about when they say to choose it. Because technically you could put it anywhere on the grid you want to, but 0, 0 is a pretty easy way to do it. The bridge has a span of 120 feet. So if it has a span of 120 feet, what does that tell us about the picture? 60, yeah, and that's left and right. So it goes 60 this direction and 60 this direction. And it tells us that it has a maximum height of 25 feet. So what does that tell us? Yeah. Okay. Now, they're asking us to find the height of the arc at a distance of 10 feet from the center and 50 feet from the center. So, which letter did they give us? Which letter are we finding? Yeah, so these are specific x values. They want us to find the y value. So, what did you say? Yeah, we want to write the equation because we want to plug stuff into the equation. Okay, so we know we're going to have something plus something equals 1. How else can I write the equation? Yeah, x squared and y squared because I centered it at 0, 0. What else can I put in the equation? 60 squared goes underneath x. 25 squared goes underneath y. So how are we going to find our first solution? Yeah, plug in 10. Plug in 10 and then plug in 50. So for my first answer, I'm going to do 10 squared over 60 squared plus y squared over 25 squared equals 1. And you can write this all out on your paper and then plug it in, which is what I'm going to do because I don't feel like standing up and getting a calculator. Or you can plug it in your calculator as you go. It's up to you. So if we want to get the y squared by itself, what could we do? Yeah, take this whole fraction, move it to the other side. So we have y squared over 25 squared equals 1 minus that whole fraction. And if you want to type it into your calculator as you go, that would be fine. What else could we do to get the y closer to being alone? Okay, so multiply this side by 25 squared, multiply that whole number that you got on your calculator by 25 squared. So now we have y squared equals that whole mess. And then how would I solve for y? Square root that whole thing. Okay. So 10 feet from the center of the bridge. The height is, anyone have it? 24.65 feet. And that makes sense, right? Because the very highest number is 25. So we can't have an answer over 25. That would be wrong. And at 10 feet from the center, we haven't gone too far away from the center, so it kind of makes sense that it would be a pretty high number. When we do the other one, when we are 50 feet from the center, would we expect the height to be pretty high still? No, we'd expect it to be a lot lower. Now, the nice thing about me writing my work like this is what do I need to do to plug in 50? Just change the 10 to a 50, and you can plug it in exactly the same way. Okay. So you got 5 minutes to go ahead and finish that problem and write your sentence. I put some problems on the board. Those are not mandatory, those are optional. I'm going to hand out the take-home test now, so if you have questions on word problems on the take-home test, you should look at those problems in the book, and you can ask me questions on the book problems as opposed to asking me questions on the take-home test problems. Does that make sense? So those are not mandatory. Those are to give you options that you could do to have something to ask me a question on. Okay? All right.